Good afternoon, everybody. Today, we're going to talk about problem number 3 of 2022 February USACO Platinum level competition, phone number. Next week is the US Open. Hopefully everybody is prepared and we'll have a good result. So today we're going to talk about problem number 3 of the February contest. So this problem is you basically have a phone pad, right, which is 9 numbers 1 to 9. Don't ask me why there's no 0. So when Betsy, every time Betsy press it, you can press 1 number or 2 number, right? 2 number can be like this, 1, 2, or 1, 5, right? Or you can press 4 numbers, okay? So when you have a number, for example, end with 1, 2 like this, it could, if you just look at this 1, 2, he could press the ones, which is press 1, 2, or he could press the 1 and then press 2, right? So, for example, if you look at this 6598, he could press once, right, 4 number, or he could press this 2 number first, 5, 6, and end up with 6, 5, and press this first, okay, or he could press the individuals. So the question is, what are the possible ways to create this number with all the pressing he did? Mod by our standard 10 to the power 9 plus 7. Okay. So obviously this is a DP problem, right? So if you know all the combinations before that, then you can get the combination after it, right? So as always, as we said before, to do a DP, there's 2 things. One is, can you define the unique state? Okay. So the second is, can you do transition from one state to another state? Okay. In this case, we can define a unique state if we know which number, the ith number, right, is present. But the question is, how do we convert from one state to another state? Every time, if we look at convert from one state, let's say if we add the ith number, okay? The ith number, first case is he pressed, right? Just press this number, 1 number, right? That's one case. The second case is if this ith number and the number before it can form this, can be 2 neighbors, okay? Then there is a possibility that he pressed twice, press those 2 as 1 number, right? The other case is if the last 4 number is formed like this, right? He can press it. Okay? So obviously you can add all those together. When I say add, the problem is this combination, right? 1 number and the 2 number, right? So for example, you could press this number, but you could also press this number, right? If this is the case, but let's say you have a function called is neighbor 2, okay, to check, whether it's that, or and you have a function, that's easy to write, right? Function is neighbor 2 or is neighbor 4. So the case you have 1 number was the case you have 2 number, if is neighbor 2 is 2, there's overlap, right? So we know how to do this by using inclusion, exclusion. But what's more complicated is what if is 4? So is 4 has combination of 1, 2, and 4, right? So basically, if you want to count, if you have 3 possibilities, right? Let's say A, B, C. Okay, let's say this is A, B, C. We know by inclusion, exclusion, right? A and B is A plus B minus A and B, right? So A or B or C is A plus B plus C minus A and B minus B and C minus C and A and plus A and B and C, right? So that's basically what you need to do. The logic is very complicated to write this, but the concept is very simple. In order to do that, let me just write the pseudocode for you guys. We haven't wrote pseudocode for the last 2 or 3 problems, I think. It's fun. Let's just write the pseudocode. It has n cases, right? Has t times t possibility t cases. So let's say we first see in n, right? In t equal 1, t less equal t plus plus. That's my t0, right? So what we need to do is we first has to input this string, right? We got this string first, right? So then let's say my so then I start dt, I need to set all of them to 0, right? Everything to 0 first. Okay. So then I will do for my first one, well, there's obviously there's only one possibility, right? You can only do one of them. Okay. So then from again, I'm just writing pseudocode here. So first is what is let's call it when you convert it into a number. Okay, let's say AFI, right, equals S of I 0, right? So let's get what is real number. So first, if you just do it, use one number, right? If you do it with one number, is basically I need to add I minus 1, right? It's the same as, so all the previous case, right? So what I'm not doing here is you need to define the, which I'm not going to do. Basically, you have to make sure all those add and the minus, what I'm writing here, that's all mod. You have to mod by 10 to the power 9, right? Plus 7, which I'm not going to do here. So let's say, let's first check, if is combination of 2, okay? If it's combination of 2, right, as we said here, so we can also, we first need to add, right, the possibility of 2. So dp of I is equal dp of I minus 2, right? So those two numbers, if it's for example, it is, okay, right here. So for example, the number is, if the number I show is 1, 2, right? 1, 2 have two cases. You can be 1, 2, or you can be 2, 1, right? So then you have to obviously times 2. Again, everything when I do times here is also is all modded, right? You will implement that by yourself. Okay. So if it's combination of 2, let's say what if it can be done as combination of 4, you know, like this case, right? If you check the I minus 1, I minus 2, I minus 3, if it come from the 4 neighbors in the pad. So so I'm going to do like minus 4. That is times 24. Okay, you can count it, right? So basically you're doing 4 times 3 times 2, right? So 4 factorial, that is 24, right? So you have, you know, if you have 1, 2, 3, 4, okay? So let's say 1, 2, I mean, not 1, 2, 3, 4. If you have, for example, 1, 2, 5, 6, right? That is form something there. So if you have 1, 2, 5, 1, 2, 3, 4, 5, 1, 2, 4, 5, right? That's a factorial for that's 24 combinations. Okay. So now we need to do this subtraction, right? So we need to do subtraction. So now, so first we do this subtraction, okay? A and B. If it's 2, right? Okay. So basically we have to extract, right? So dp minus equal dp of I minus equal dp I minus 2, right? So you remove that, okay? So then if is combination of 4, and that gets much more complicated. If it's combination of 4, so first you remove the double count, right? So let's remove, let's see, minus equal dp of 4. And remove the combination of 4. Then, but you could remove more if the one before it is also a check 4, right? So if the one before it is also a check of 4, then you have to remove you have to remove more of it. Let's see what we need to remove. For example, if you have 2, 3, let's say 2, 3, 5, 6, right? So if you have the 2, 3, 5, 6 block, okay. So if 2 is before, let's say 2, if 2 is before 1 to 4, right? 1 to 4, remember, 1 to 4 is before. If 2 is before that, and then you can make like this. You can make 1, 4 to 5, for example, right? So if right now, if you have this, okay, and then if the one before it if you have 1 and 4 before it, this is also a neighbor of 4, right? So you can make there's 4 ways. There's 4 ways. That has 4 ways, but the one way you already counted it before. So what you need to do is you have to count the one before, which is let's see. It's 1, 2, 3, 4, 5, right? So you have to minus the API minus 5. Right? Of course, I'm assuming you have the code to make sure you're assuming the I is bigger than that. So there's 3. So there's 3 possibility left. Okay. So that's this case. Let's see. Then the next case is what if it's the one before is count of 2, right? The count of 2. If it's it's count of 2, I minus 1. If it's count of 2, then I mean neighbor of 2, then you have to remove that, right? So basically I minus 4, right? So you have to remove that. What if it's not count of 2, then but if it's count of 4, if it's count of 4, then you have to remove the one before that, which is I minus 5, right? So now we make this case, we move one step to get forward, right? I minus 1. Let's check I minus, this is I minus 1, right? I minus 1 we checked is combination of 4 or combination of 2. Okay, then we check I minus 2. Okay, let's check I minus 2. I minus 2 has I minus 2. So if it's neighbor of 2, okay, if it's neighbor of 2, then we will, right? Then we will remove minus 4, right? Otherwise, if it's a minus neighbor of 4, okay, if I minus 2 is neighbor of 4, if it's neighbor of, no, we check I minus 1, right? We'll check whether I minus 1 is neighbor of 4 or not. If that's the case, if that's the case, then we will obviously double count it. I minus 5, right? Okay. Then what about in this case? as similar as above, right? So what's the step before it? Just similar to that. If the step before it is a -4, then what we need to do? Then there are, I think there's 2 cases, right? So I-2 has 2. Then this I-2 has 2 cases. Is if the one then the 2 more before it is check 2 or is check 4, right? So then if that's the case, because 4 numbers, right? 4 numbers. So 4 numbers is like the 2 number before it, is neighbor of 2. Then what we need to do is we need to take dp. We need to minus the I-2, then -2, right? Otherwise, then is that neighbor of 4? If that is neighbor of 4, then we need to actually we need to do dp of should be dp of I-6, right? Same as that. Then we actually need to do then we need to check actually the 4 before. Actually, we need to do a iteration here. So let's say this is calculate 4. Okay, so I need my original number, right? X number. I need my I. Right? So let's copy it here. So if it's an A, right? If it's X-2, okay, then dp of I is this X-4, right? Otherwise, if it's neighbor of 4, what we need to do is dp of I is this X-4, right? So then what we need to do is we need to call for again. In this case, my X is -2, right? Then my I is the same. So of course you have to check, your X cannot be, your X-2 cannot be less than 0, right? So, okay. So then we need to do that calculation. We need to, in this case, we need to calculate 4, which we need I-2 and I. So in that case, okay. So then that is, if that's the case, what if it's not? What if it's not, I-1 is not a neighbor of 4? Then in this case, is we need to check I-2 is neighbor of 4 or not. If I-2 is neighbor of 4, then we will do similar as above, right? So we will do dp of I, or dp of I-2 the minus 4, right? Then we're going to do this calculate the fourth thing, which is I-2I. Okay. So in this combination, we figured out if it's so in this combination, okay, in this combination, we figured out I-2, right? So we did I-1, and we did I-2. Then the last thing we have not done is, what if it's both 2 and 4? Okay. So if is NA is N2, right? Is 4. Okay. So we obviously overcounted, right? Now we need to add it back. So there are going to be 2 cases. Okay. So we have 2, 4. So there's a second case. Is basically I can do 1, press 1 number, press 2 number, and press 4 number, right? 1, 2, and 4. Okay. So let's first look at this first. Obviously, we're going to remove I'm a combination of 4, and then we need to do this cal 4 thing, right? Is in this from here, right? From instead of I-2, we need to do it from right here. Then actually then I need to do it, right? So there's 2 possibilities, right? We need to do it, then we need to do, we actually need to do it twice, right? So you can do 2 times. Okay. So then what if is combination 1, 2, and 4? I mean, we need to add it back, right? So then dp of I, right? So dp of I-4. Then we need to do this thing, right? But we need to add. We have to. Okay, so let's do the add. Okay, say 2, 3, 4 add. Okay, so let's do add. Okay. For so if it's I-2, then we will do this plus that, right? So if it's a combination of 4, what we need to do is we need to add, right? And in this case, if it's a combination of 2, then you need to add of 6, right? So it's 2 minus 2, then minus 4, right? It's 6. Okay. then we need to do the call for app. Right. So actually, we need to do it this way. TP of that, then we do call add. Yeah. So if it's that, then we do the add it back, then we do the add. Yeah. So then you do it that way. So you add it back, right? So let's see, is there any other case? 2 and 4, 1, 2. Okay. So then in the end, you are just going to, once you finish all this, then you're going to see out. So let's see. Right, then you're going to see out. Okay. So that's basically what they do. It's a very, I would say it's a very difficult logic, and I hope I did it correctly. So you have to think about the inclusion exclusion and just figure out what is correct and what is not correct. So you treat it. So basically, you this is do it one, right? You do it one, and then you look at you look at this number, then you look at the number. Then the combination of 2 is easy, right? Because this is the difficult one is if it's a combination of 4. Okay, you could have this overlap, right? So you have to look at I-1, you have to look at the I-2, then you have to look at if there's a combination of that. So that's pretty much the pseudocode. The logic, I would say logic is quite complex. It takes me quite some time to figure out this combination of logics. So hopefully, so the homework for you is really to go back and think through the logic and check whether I made any mistake here or not. And then implement it your own code, right? So the bunch of, because this is pseudocode, there's a bunch of simplification I did, right? I did not implement any of the mod, but that's very straightforward, right? Everybody knows how to do that. So good luck for next week's competition, right? After we finish next week's competition, we will again explain how to do it, one problem a week. Then after we finish, just a little bit planning, just a little bit of planning ahead. After we finish this US Open, then we're going to talk about the ROI problems. Okay, so the ROI problem is at this site. So so we're going to talk about the 2021's ROI problems. There's day 1 and the day 2. Okay, they're all on the online judges. I use the OJ online judge for that. So basically, in next week is the competition. Then in April, right, we will spend 3 weeks to talk about the 3 problems for the US Open. And then we're going to spend 6 weeks, right, to talk about the 2021 ROI problems. So that goes, then that's summer. Then you're going to have your finals and final week, right? The final is here. Then you're going to have your summer break. Okay. So good luck, everybody, for next week's competition, and we will see you at a week after.